Right, okay, we've got a Fender Passport Venue power module on the bench. I've been playing around with it for about half an hour. I've got the complete mixer panel down there, and what's happening is you turn it on, and after about 30 seconds it starts going off and on. The power light on the back panel with all the mixer inputs and controls starts flashing, right? But the interesting thing is that this amplifier seems to be working. If I just power this up now, plug a speaker in there and feed the signal into the input cable, which is this one, you can see left and right, then the power amps are working. But as soon as you plug the power panel in, or sorry, the mixer panel in, you get this powering up and shutting down and powering up and shutting down. And it's not the power panel, I don't think, because what I did was, there's a, on this connector here, there's a plus and minus. You can see I've had the connections out, but there's a plus and minus 15 volt rail. The schematics for this, for the actual mixer board, are on Electro-Tanya, but the schematics for the amplifier power module haven't been released. I can't find them, so I'm working blind on this. But from the other thing, I noticed that this blue wire here is 0 volts, the black wire, the purple wire next to it is plus 15, and the green one is minus 15. And that power supply is, when you plug this plug in, it causes this cycling thing to go on. But I connected up my bench power supply with a plus and minus 15 volt rail, and it was only taking like 300-400 milliamps per rail, so it doesn't seem to be excessive. And in fact, if I turn the bench power supply on to support these rails, it then works. The whole thing works. So there's something wrong with perhaps the plus minus 15 volt supply. So we're going to take this apart, have a look inside, and see what we can find. Back in a moment. I've taken the lid off. Right, Fender Passport, here we've got it. I've got it out the case, and I have the luxury of the circuit diagram, because I reached out to someone yesterday, and I've been poking around this for a bit. I've done a couple before, but it was a while ago, and yeah, they gave me a circuit, so we can have a look at the circuit as well, the schematic as they call it. The problem, as I explained before, was that here's the two speaker outputs for the main amplifier. This is the main amplifier in this section here. This board basically is the main amplifier, and the stuff more or less on the baseboard is power supplies. All right. Now, if I put some signals into the screen inputs, I hear some sound coming out the speaker. But as soon as I plug the mixer panel in using this plug here, which has got plus minus 15 volts, 5 volts, and 50 volts for a powered microphone, after about 10 or 15 seconds, the light on the power panel starts on the main mixer panels, I say, starts to flash. And if you monitor the 15 volt rails, they're going up and down as it flashes. So something somewhere is drawing too much current, or something somewhere can't provide enough current. Now, if you look at this, this is a typical sort of design for these amplifiers. We have essentially in here, you got the input filtration and all that, and the big reservoir capacitors, and a bridge rectifier bolted to the back of the heatsink down there. And what we've got is two power supplies in here, two completely discrete switch mode power supplies. We've got one small power supply whose job it is to provide the DC mixer electronics with plus or minus 15 and 5 volts and 50 volts. So this goes, the power from this goes through this transformer, through some rectifier diodes on the board down here, and then down a series of regulators to the outside world via these headers over this side of the board here. So I think we've got a plus or minus 15 volt for sure. They're very crude supplies actually. They're just a Zener regulated base junction on emitter followers for the plus and minus rails, and a 7915 or 7815 I think, a 1 amp 5 volt regulator. So it's pretty straightforward, and it was this power supply which was wilting under the load. So was it being overloaded or not, I don't know, but this provides the power to the mixer board, and also provides via a separate winding DC power to power the main power supply management chip. And this is the main power that's just switching into this transformer by which FETs, where are they, where are the FETs, there they are down there, two big power FETs down there, N channel FETs. And as usual, the gates of these FETs are driven by a small transformer here, from here. So this is driving. So the power to drive this drive circuit, to drive that, is coming from here isolated, and this also supplies the electronics for the mixer board on the front, the lights, USB interface, and all that stuff, right? Okay, so what I did was I unplugged the mixer board and connected my bench load to this across the 30 volts plus or minus 15 and loaded it, and when it got to about 350 milliamps was the maximum at 30 volts that it could supply. So that would be, if that was 1 amp, that would be 30 watts. It was 330 milliamps, so it was about 3.5 watts, I think, of power, right? So was that right? No, that's wrong. If it was 10 watts, something like that. So about 10 watts of power coming through this. And this is supposed to be a 90 watt power supply, okay? So why is this wilting under the load? Is there too much load being drawn by this amplifier drive circuit, or is there too much load being drawn, current being drawn by the mixer board? Well, I've checked the mixer board, and with the number of op amps and circuitry on that board, I would have thought 300 to 400 milliamps per rail at the plus or minus 15 would be reasonable. So my guess is that this power supply is in somehow wanting, not supplying the current. And to cut a long story short, if we just go over to the circuit diagram, you can see here's the overall circuit diagram of the Fender Passport power board, alright, power module. And here's the power supply. This is the auxiliary, I call it, the power supply, single chip, GaN FET type design, driving into the primary transformer. Then all these various rails being drawn off from this power source, okay? And one of the power sources goes over here to power the PWM chip in this location, just there on this part of the board. So if we zoom in a bit, we can have a bit of a closer look. Okay, so here's the power supply. The chip is this chip. This is the chip. It's RS part number 7532964, and it's an ICE 3BR0665. Now the chip that's in there, if we look on this diagram, you can see it's a ICE 2B365, and we've got BR0665. So we've got the 665. The chip is more or less pin compatible apart from pin 1, I think it was. Here it's just got a simple soft start circuit. On the new 665 chip, it does something different. So I'm not sure. It doesn't say in the applications note whether you can just swap it straight out, but one thing's for sure, this is obsolete. They had a family of these at different power levels, from the lower power to the higher power. This is the higher power one. Now they've replaced this by one brand new chip with a slight difference. So we're going to have to look at what pin 1 does before we change this. But if this is the case, if this is what the problem actually is. Now you can see it's driving to the primary of this transformer. Down here, transformer we've got for this power supply, and here you can see the various rails. We've got the V driver, which I think is a 50 volt rail for microphone drive, or is it that one there? It could be that one there. Yeah, V driver, that's the power supply perhaps for the switch mode power supply over the other side of the board. That's what that is. And then we've got plus or minus 15. You can see there's just a couple of transistors. They are actually, they're tip transistors, just ordinary bipolar transistors with the emitter followers. So it's not truly regulated. It's just by the accuracy of these Zener diodes, and the stability of these diodes will dictate the plus or minus 15. I don't know whether there's further regulation on the mixer board or not, I don't know. But that's where I was loading it, on these 2 points here, the plus or minus 15 on the right hand of the screen. And I found that this was folding, this power supply was starting to drop at lower current than I was expecting. At the time I wasn't taking any 5 volts, and I wasn't taking any anything out of the other power supplies, and the fans weren't running. Also, this is powered by a small circuit and a thermistor going to the fans. Okay, there's 2 fans on this, and neither fans were plugged in at the time. So either this can't provide the current, or the main amplifier driver circuit, which is also provided by V driver, is drawing too much current. When you leave it alone and don't load it, the amplifier seems to be working all right. So possible culprits on this is probably going to be this chip. They do go a bit funny. They are doing quite a lot all in one package. Remember, it's got the drive FET, it's got all the conditioning circuitry, the power supply, everything else. There's a bootstrap supply coming around here. Look, you can see via this 22 ohm resistor. So it could be this capacitor has gone and it can't provide enough current if this has gone open circuit or very low capacitance. So we'll have to check that. There's a protection diode to prevent overprotection. They put a 22 ohm resistor just to make sure that that diode doesn't get blown if there's a major surge. It gives it some protection there. And then a soft start cap with pin 1, which we're going to have to manage, find out what that does. And this is a current sense for the primary. So there's a small low ohmage resistor in there. I don't know what it is. 0.33 ohm, 0.5 watts. Clearly, if that diode has gone bad connection or is not correct, then this will start to fold back the power supply before it should. If it's gone high in value, it won't fold. It will fold back the power supply before the full power delivery is being delivered into the transformers. I did have a scan with the heat gun, couldn't see anything getting warm. You know, if there was an extra 10 watts being drawn out somewhere, you'd expect to be able to witness that as a raised temperature in one of the other components. Okay, so yeah, so at the moment what I'm going to do is I'm going to change this component, do a modification if necessary once I've researched it with this pin 1 connection with that capacitor. I'm going to check this resistor, check that capacitor is okay, and probably check that 22 ohm resistor hasn't gone a bit funny if it's been getting warm. Unlikely, but you never know, it might have gone up to 39 ohms or something stupid. And the bootstrap supply can't keep this thing running. And if we just scoot over to the other side of the circuit, there is the drive circuit for the main power supply for the main power amp, based around this chip, the UC3844. It's a quasi-resonant switch mode power supply drive chip, and you can see the output goes directly driven in through this capacitor and diode network to the input of a transformer. Okay, and so that's T602, and then if we scoot up here to the top, you can see this dotted line denotes the secondary of T602, and then we've got our two very powerful FETs being driven into the power supply as a half bridge. Okay, so because the outputs, the drain of this FET is and source are going up and down with the power supply, we're actually basically switching an AC waveform directly into the primary of the transformer. So the FET gates are driven by an isolated transformer, which is T602 on the board, a small drive transformer, so that we can derive these gate signals. And then into the power supply, and then coming out through the rectifiers, regulators and what have you for the plus and minus 50 volt main power drive for the main power amp. So I'm just going to stop recording there and just remove this chip and replace it, and then we'll resume when we come to do the pin 1 modification if necessary. So the new chip is in. A bit fiddly to get in there because you have to get in under the heatsink to put it back, but while I was just cleaning this board, I just noticed something. Have you noticed it yet? I don't know what size your screen is, but look, just here. Can you see? Looks like something has been happening there electrolytically, I would say. Something's not quite right, is it? Is that track, or can you see it's there's been a blob of something left on there eating away at the etch resist or the solder resist? Difficult to know really. There's definitely something there. That solder resist screen is either a bubble on it or something, but you can see a stain from that track down through to there. So it's a slightly unusual one, but unfortunately I cleaned the board before I noticed it, so I might have cleaned a lot of the detritus off, you know, in terms of carbonisation if there was any. But there is something definitely strange happening at that point. So what I'm going to do is to move this wire back away so that we increase the gap. There's a small gap there. Push that wire away, and then it looks like the track has been etched. Is there copper under there? No, there isn't. Is there copper under there? No, that's just PCB. So that copper has been eaten away around that from that track. And there's kind of a rough surface on the board there as well. That's not smooth. So it's probably been sparking and also eating away at the FR4 PCB material, the actual board material itself. So what I could do is cut this track and lay a piece of insulated PTFE insulated copper wire across that track. I think of what I'm going to do so that we can isolate this section, because I could lacquer it, but will it work? Don't know. So if you've got one of these, check that bit of tracking to make sure that you haven't got the same issue. If it's happened here, it might happen there as well. So I'm just going to do that now. Yeah, so I've removed the track underneath and then linked in with some PTFE insulated copper wire between the 2 points on the board. I think what might have happened was that there was a bubble or an uncoated area or an error in the epoxy coating. There's an epoxy extra resist. This is this green coating on top of the copper, and it's quite matte on this board. Normally I always prefer to go for shiny, because I don't, it just, you can see better the thickness of the actual coating when it's shiny. But there may have been a bubble or an error in the actual solder screen printing on the etch resist and solder resist, and something's happened there and some leakages occurred across that board, so I don't trust it anymore. You can see actually up on this point, up in this section here, the tracks are still quite close together, so where it's coated it's not a problem. It's the fact that the coating was missing or had something else stuck under a bubble of the solder resist coating that caused the issue. So we put that back in, we've changed the chip. Now we've got to decide what to do with this pin 1 issue. Right, here's the chip that's in there, the standard part, and as I say, it's been obsolete for some time. I don't know how old this Fender Venue unit is, but this chip is obsolete. And you can see here, look, pin 1 was the pin I was telling you about. 1 is soft start, and in the circuit diagram in the Fender, from pin 1 we've got a 1 microfarad 50 volt capacitor, multi-layer ceramic to ground to 0 volts. To slow the start of the unit, as it powers up it will increase the drive to the FET, so that you don't get an immediate overcurrent if the output capacitors over on the other side are all shorted because they're discharged. You've got to provide that charge, and you don't want to drive this into current overload, which is basically generating a higher than threshold voltage across R641 down here, which is the current sense resistor. Okay, so pin 1 is soft start. Now this is the, I'll just scoot up and you can see the part numbers. So that's what's in there at the moment, okay, but that is obsolete, well obsolete, couldn't get any. So they've replaced it with this, which is exactly the same, I think, pin compatible, except for the pin 1 is no longer called soft start, it's called BA, which stands for blanking and auto restart. So it has a similar function, but inside this chip there's already a 20 millisecond blanking time built into the actual chip itself. So in theory, the blanking time actually is when you have an overcurrent situation going on. It's the time that you allow the thing to remain dormant until you start trying the power up cycle again. So on this one in particular, you can also induce this soft start cycle by microprocessors by bringing the BA pin low. You can actually initiate the auto restart, so it's a control pin, or you can increase the soft start by putting a capacitor across between there and 0 volts. So what I'm going to do, I think, because it's got built-in soft start and we're not doing any blanking because there's no blanking control from any of the electronics on the actual power supply, I'm going to remove the capacitor from the Fender, and then maybe scope it just to see that it is doing a soft start and see if I can identify any issues, and if I can't, then down here somewhere. Alright, so what I'm going to do is the soft start pin is connected to 0 volts by a 1 microfarad 50 volt capacitor. I'm going to remove that capacitor, rely on the internal soft start on the new chip, on the new device, not this one, the 665 is the one we put back in. This cap here, 47 microfarad 25 volt, has been checked. That's okay. That diode is okay. That 22 ohm resistor is okay. And the 0.3, the 330 milliohm current sensing resistor measures out correctly. I've checked it with the bridge. All right. So there. So that's that. I'm going to remove this and then fire up and see what happens. So back in a moment. Well, it's fixed. It's fixed. It was a bit of a long trek actually, putting the extra chip in and getting the chip to work reliably. The problem with this is that the these circuit boards, you see it's all working now, so it's got power, everything's working normally. Just done an audio test on it, it was fine. That's for the phantom power for the microphone. And up this side is the USB and the other controls for playing and stop media. So yeah, it's all working. The mixer's working, and the power amplifier back here is working too. But careful, the lid's not fully on at the moment. So it's all done. I would, if you've got one of these, working on this now, it's all coming back to me. The sort of problems I had before, and one of the problems, I'll talk about the electrical circuit in a minute for the power supply, because if you can't get that chip, you're going to have to do the modifications, and I'll just tell you what they are to make it work reliably. Otherwise, it won't start up and strange things will happen. So you're going to have to change a couple of components on there, I think, to make it work. Yeah, so the new chip is all right. It's just different, and you know, it's kind of like just checking the design all over. So it's been quite involved. So yeah, the circuit board inside the power unit there is super wafer thin copper. It's almost like aluminium foil. Single-sided board, but yeah, it's a couple of cracks on the board. We had that problem with the leakage across those tracks. The track layout is bad, and the tracks all around the primary power supply, not the one that drives the amplifiers, but the primary small one, are very, very light tracking, and doesn't look like it's been laid out with the constraints of the noise in mind. In fact, I had to add another capacitor because of the impedance for the smoothing capacitor on the board. I'll show you where that was in a minute. But another problem with these is, I remember now, these connectors can get pulled, and if you've done anything with them, the tracks can crack along there, and they're fine hairline cracks. You can see I've repaired that one there before. Yeah, so check your connectors are actually making contact. So meter the voltages, or do a continuity check between where you can see the track on the board and the connectors on the side, because if you pull on those slightly, they crack. And the vibration, I'm guessing, might get to it too as well. But yeah, comment really is very, very thin, very delicate circuit boards, so be careful with them. And also, this one was caused by this fault was caused by a fault on the manufacturing fault on the circuit board. So if we just go over to the computer and have a look at this, I'll just show you what there is. This chip here, the ICE 2B365, we replaced with the one I showed you, ICE 3BR0665, which is the part which has superseded this obsolete part in the design. Maybe the later ones had a newer part in, I don't know. But hold on, let's just turn that scope off. Yeah, so on this circuit, I'll just zoom up a bit more. I'll show you what I did. So you take out, you change the chip, take out the 1 microfarad, 50 volt capacitor down here, and I fitted a 0.22 multi-layer ceramic, because without it, it's not reliably starting up. It starts up most of the time, but if you put the voltage slightly low, it wouldn't start because the capacitor was too high. Without a capacitor was too short, it wasn't enough to get all these capacitors on the secondary side charged before it shut down. So the circuitry in here and the bleed current down to charge this capacitor when it starts is a different impedance to the 5 volt supply. So yeah, you've got to change it for a 0.2, 220 nanofarad, a 0.22 microfarad, 50 volt capacitor, right? Now I noticed that when it was running on sort of full load, I loaded it up with the power supply, and there was quite a noise, and kind of it was jittering slightly. I know it's got a spread spectrum type frequency hopping clock to help with the MC issues, but I found that 22 microfarad 400 volt, that one, and comes through a choke onto this, and this capacitor had an ESR of about 4 ohms, and at 100 kilohertz it was like it wasn't even registered on the meter. The ESR was so high. And there's a lot of switching noise on this, which is getting through into the ground plane, and particularly onto this this regulating pin here, the actual feedback pin from the secondary side, and the over voltage check demand pin, feedback pin. So I put across that C639, I fitted a 0.047 400 volt polyester capacitor straight across that cap. So 47, and that quietened this down quite a lot. I don't know if the new chips are more susceptible to noise. I don't know, but it quietened it down, and it's working fine now. So that's the two things. Add a 47 nanofarad across that cap, C639. Replace C662 with a 0.22 microfarad 50 volt multi-layer ceramic. And then also on these power supplies, I remember before, check D611 and also D623, which is an ultra fast 1 amp 1000 volt silicon switching diode, but they are prone to go iffy, and it's an unknown make, the one I found, made in China, and it was leaky. So I've changed it. And I put in an Infineon part instead. So it's got a decent. These diodes, these fast recovery diodes, are susceptible when they're used in some snubber circuits, and they go leaky or don't switch off properly, and that puts extra load on your chip. All right, so check those diodes out, is my advice, and be careful with the soldering iron, because the tracks are wafer thin and they come off at the slightest suggestion of any pressure. I don't think I've worked on a board quite as delicate before. So in the end, I unsoldered the other components, because I did do a bit of damage to one of the pads on the chip when I took it out. I unsoldered the other parts with solder braid to prevent the tip of the soldering iron pushing on the board, because it comes off so easily. It's very finely tracked. It's just got enough copper to hold it on the board, I think. And I think if they made these PCBs, particularly the power PCB, with a thicker weight of copper, so the actual tracking was thicker, I think it would be a more reliable design. Okay, so that's that. So if you do those bits and you've got the same problem, the power light is coming on or it's not powering up at all, then check that circuit out, have a look at the components, if necessary change the chip, but you need to check that you've got on this connector here, if when you power up, the blue wire is 0 volts, pin 4, it's just turned on actually, be careful. Yeah, blue is 0 volts, plus 15 is the purple, or is it black? Purple. And the green wire here is minus 15. And if you don't get those 3 voltages on the board, then the primary power supply is not running. It's nothing to do with the secondary, it's the primary. Okay, it's not the main amplifier power, it's this power for this control board and for the fans as well. So yeah, check that out, and also check that there's no cracks in the board where if these connectors have been pulled at all. The tracks are so thin they just crack along the front. You can see I've repaired that one, and that's just from me plugging that in and unplugging it. So beware, buzz these out further down the board somewhere to make sure you've got proper reliable connections on these. That's the audio output feed to the amplifier for the from the mixer. All right, and yeah, don't forget to reconnect your earth stud. That's a good one. I hope you like that. If you've got one, then good luck with it, and check your power, because it obviously, I think I've seen a couple, and it seems to be a common problem. So if you liked it, then subscribe. If you've already subscribed, thanks very much, and leave me a like.